Okay, welcome back everybody. This is second operation for the clamp part. So we will start off by making a new toolpath group. Right click on the machine group, select groups, new toolpath group, and then we'll flip it over like this. And what we're going to do is, before we actually program the parts, we're gonna make a soft jaw program. And so we're going to cut 3 little pockets into a set of soft jaws to hold and locate the parts. Okay, so first thing I'll do is I'll create the plane, the planes, and from solid face, I'll select that one right there. Alright, that's fine. Hit the equal sign, set it to my current plane. Okay, so soft jaws. So the way that works is we have, so you can imagine these two rectangles are a set of jaws. We leave a little gap in here, usually about the width of a parallel, so we'll clamp a parallel in there. That way, after you machine the pocket, the jaws still have a little bit of squeezing they can do. If you were to just close these jaws against each other and make the pocket, then you might not actually clamp on the part, you might just be clamping the jaws together. Parts could fly out. So we leave a little gap. And so our origin is going to be in the center of that gap. Okay. So I'll hide that. I like to keep my screen clutter free. So get rid of that stock for now. Alright. So what we want is a pocket to hold the part. So I'm going to create some wireframe geometry in order to make that pocket. So go to wireframe, I'll make a rectangle, come here to there. Alright, and we'd be done if we could figure out a way to make sharp corners with a round tool, but since we can't do that, we're going to have to make some reliefs in the corner. Okay, so the way I normally do that is I will come in here and I'll draw a circle. And I'll draw the circle a little bit bigger than the tool that I plan to use. It's a fairly small part, and I don't want a big, huge relief in here, so we'll probably use a 1/8 inch diameter end mill to make the pocket. So I'll make that circle a little bit bigger than 1/8 an inch, maybe about 160. And I'm going to go ahead and lock that in. And I'll usually zoom in. Basically, we just want to make a relief for that corner, right? So we don't need to come here, because then we have all that unused area. So what I do is I'll bring the circle in here somewhere kind of close like that. Again, it's not super critical, you just want to make sure that the sharp corner falls within that circle. Okay. Then I'll go ahead and copy this guy. From here to there. Oh, that didn't work. Oh, let's get rid of that. Let's do a mirror. So transform mirror right there. And, okay. So mirror along the X. That's good. I'll hit the blue check. And then I'll grab both of these. Selection. Now I'll grab off the Y-axis. And my position will be right here. And now I got my 4 circles. So green check it. And then I'll go ahead and trim it. Do a divide, I guess. Let's see here, here, and there, and there. That. Get rid of that. Get rid of that. Okay. Oh, what happened there? Looks like I lost that guy. Problem. Just draw a line. Green check. So I'll hit the shift. Select that. Highlights the whole thing. So I got a continuous chain. Alright. Looks good. Okay. Clear the colors. Alright. So now I'm ready to make my pocket, my program. Let's see. Our part is 1/4 inch thick, right? 1/4 inch. So after we make the pocket and we put the part in there and we machine the top of the part off, we're going to want to come back and deburr the edges of the part. So we don't want to make our pocket as deep as the part, right? So we want to leave a little bit of the part sticking up. So we'll make our pocket probably about 200 thousandths deep. Okay, so let's go ahead and do that. Toolpath, dynamic. On my machining region, I'm going to go to wireframe chaining. I'm going to select that chain, green check, and I want to stay inside. Green check. And my tool is going to be a 1/8 inch flat end mill right there. Okay. I'll probably bump this up a little bit. So you can see those speeds and feeds. For my step over, I guess that's alright. I might bump it up. I might bump it up to 20 thousandths step over. And then for stock to leave on walls, I'll say 5 thousandths. Alright. That all looks good. I don't need any of this stuff here. Linking parameters, like we said, we're going to go minus, I'll say 0.19. Minus 0.19. Got the arc and filter settings. And coolant is on. Alright, so there's our pocket. So if I go ahead and there's our rough pocket. And then we'll come in and do finish pass. So contour. And check. Tools, same tool. I'll slow it down a little bit for the finish pass right there. Let's see. My end mill is probably a 2 or 3 flute. Oh, it's 4. Okay, well, should be a 2 flute, maybe a 3, but yeah, that's better. So obviously the number of flutes will affect your feed rate, chip load. So for cut parameters, I'm going to use wear compensation and 2D. Change this. 10,000 sounds better. Lead in, lead out. And then multi-passes, I like to do a spring pass on there. So one finish, one spring. Linking is going to be minus 0.19. Coolant's on. Alright. Looks good. Alright. Snag it was snagging me up. Alright, so now we got the pocket done. And now we need to basically copy that over. Alright, so we're going to do a toolpath transform. Alright, so toolpath transform. And I'm going to select these two toolpaths. I'm going to translate them via coordinates. There's going to be 3 instances in X, 1 instance in Y. And the distance should be 1.25 plus, what was that gap we did? 0.3. Let's see if that works. There we go. So let's see. Looking at that, that looks like a bit much for that end mill to be ramping down in there, right? So I must have not paid too much attention to that setting in the toolpath. So let's go back in here to toolpath number 11 to the roughing out of that pocket. Let's go to entry motion. All right, so there's our radius, and then our Z clearance is 0.125. So we don't really need it to ramp down that much. Okay, so let's go 0.05. And linking parameters, top of stock should be 0. Alright, so green check that. And you'll see that the toolpath goes dirty, as well as the transform toolpath went dirty as well, right? So we'll just hit the regenerate with the red X to regenerate all dirty operations. So that makes sense, right? This transform is looking at these two toolpaths in order to create the pockets for the next two parts. So if we change something in those, then obviously it needs to update the transform as well, right? So it can keep them all the same, right? So that's the parametric side of the software. So now that's good, right? That lead in is much nicer. Okay, so I'm going to hide those toolpaths, and now we can program the parts. It's going to be quick, but we'll create a new toolpath group. So right click on the machine group, go to groups, new toolpath group, not new machine group. Don't do that. That's no good. New toolpath group. Alright. And we're just going to keep the origin is going to be the same. So we won't move it. Bring that stock display back up. Okay. Now we're going to have a little bit over 100 thousandths of material on the bottom of the part. So we might do like 2 passes on the face mill or the 3/4 end mill. So let's see, face, and when I highlight wireframe mode, then it says select OK to use define stock. So I don't actually need to choose any geometry since I set up the stock. Green check. Use my same tool, 3/4 flat end mill. Speeds and feeds are already there from before. Cut parameters, and it's all pretty much the same. Mastercam does that, right? So whatever your settings were on the last facing toolpath that you created, that's what you'll see in the next facing toolpath you create. So a lot of times it's very helpful. Then you just have to go in and change what you want to change. So for this, we will add depth cuts in with a max rough step of 50 thousandths. And then for the linking parameters, our top of stock is going to be 0.1. Got to make sure we put that in there because it uses the top of stock to calculate the depth cuts. All right, so top of stock is 0.1. Our final depth is Z0. And all this other stuff should be good. Green check. And there we go. So 2 passes on the face mill. And then we'll just go ahead and deburr these outside edges. That's why we made our pockets not go the complete depth of the part, so that we could run the chamfer mill around the edge of the parts. Okay. So we could do the same way. We could just chamfer this first part, and then we could do a transform, but that would actually take longer to do. So we'll just do it all in one toolpath. So contour. I'm going to choose solid mode. I'm going to choose loop. And when I highlight it, make sure it highlights this upper rectangle like that. Alright, I want to select it here on the left side so that I get that clockwise motion going around the part. Just like that. And I'll select this one and that one. Okay, green check. So we're going to go back to our chamfer mill, 1/4 inch chamfer mill. Cut parameters, compensation type is going to be computer. Okay, so if you're going to use the 2D chamfer routine, you have to use computer compensation. So our chamfer width is 10 thousandths. Our bottom offset is 50 thousandths. I might decrease that just a little bit. With our pocket depth of 190, that 50 plus the 10, which would be 60, should be fine, but just give us a little clearance. So our chamfer is going to be 10 thousandths, and the bottom offset is going to be 40. So that means the tool is going to go to a depth of minus 50 thousandths. Okay, lead in, lead out. Should be fine. Multipasses we don't need for a chamfer. Okay, and then our linking should be 0. So when you use the 2D chamfer routine, your depth has to be at the surface where the chamfer starts in Z. Okay, that's it. All right, we'll get save on there. Then we'll go ahead and do a quick little verify. Okay, looks good. If I want, go in here to verify and do a compare. Click the little refresh. It's going to give me a color-coded verification. If my part machining matches the solid model that I used to create the program. Alright, looks good, all green. Alright, so that's it. We will see you in the lab so we can make these parts.